In the previous topic, we look at the oligopoly market. So in the oligopoly market, we have a small number of large firms. A key feature here is that there exists strategic interaction among firms. That means my action affects your profit and your action affects my profit as well. So when I'm making decision, I need to consider your response to my action and your response to my response to your action, and so on and so forth. So we need to account for this sort of strategic interaction in analyzing the oligopoly market. One tool of doing so is called game theory, and this is what we want to cover in this topic. Okay, what do I mean by a game? Let's look at an example first. Okay, suppose we have two persons. One is John, the other is Mike. They are partners in crime. However, unfortunately, they were caught by the police. So now they can do two things. First thing, they can confess. Or not confess. Okay. If both of them confessed, then the judge has evidence to charge them, and they will be sentenced to say 5 years in prison. And I'm putting a negative sign in front of 5 because the lower sentence, the better. And the blue pair belongs to Mike. Red pair belongs to John. If Mike confesses, John does not confess, then the court still have evidence to charge against them. So in such case, because Mike confesses, so he's going to get a lighter sentence, which is 1 year. And John not confess, so John will get a heavier sentence, 14 years. Similarly, if John confess and Mike not confess, then Mike will get 14 years sentence, and contrast John will just get a lighter 1 year sentence. Okay, if both of them not confess, then there's no evidence. So the sentence will be light. Suppose it's 1.5 years. Okay, so this is the game. Let's look at what makes a game now. So first, we need the players, right? So first, we need the players. In my example here is John and Mike. Secondly, the games need to have a rules that include allowable actions in my example here is confess or not confess. So that's the action they can choose. And the players, they form strategies. So which is choice of actions in playing the games. And implicitly, we also assume that there's a perfect, complete information. What does it mean by complete information? Here it means that everybody knows everything. And everybody knows that everybody knows everything. And everybody knows that everybody knows that everybody knows everything. And so on and so forth. Okay, so it's complete information. And another dimension is timing. Here we only look at, this is one shot. It's called one shot game. Okay, that's the rule. So we have players, we have rules. Then when player plays rules, there's associate payoff. For example, if both of them not confess, the payoff will be negative 1.5, 1.5 years sentence. So there's a payoff associated with playing the games. Alright, so that's the elements we have for games. Okay, so we set up these games. Then the next question will be, we want to predict what's the outcome of these games. Okay. So we want to predict the outcome of these games. Okay, how can we do it? Let's do it this way. Let's check. First, if John confess, what will Mike do? If John confess, then we are in this column. So Mike will compare this payoff with this payoff. Okay, so now be aware that you are comparing correct payoff, not this payoff with this payoff, not this payoff with this payoff. Okay, we have to compare correct payoff, this payoff with this payoff. So clearly 5-year sentence is better than 14-year sentence. So if John confess, Mike will also confess. Okay, that's first question we ask. Second question, if John not confess, what will Mike do? Okay. If John not confess, then we are in this column, and we are going to compare this payoff with this payoff. So now 1-year sentence is clearly better than 1.5-year sentence. So Mike will confess. So here, from the answers of these two questions, we can conclude that Mike will confess no matter what John does. And then we call this the confess is a dominant strategy. for Mac, or is Mac's dominant strategy. Okay, so let me give a different definition of dominant strategy. So a dominant strategy is the strategy that a player will use no matter what the opponents do. Okay, that's what we mean by dominant strategy. So how to check a dominant strategy? This is the way of checking the dominant strategies. So Mike has a dominant strategy of confess. So Mike have dominant strategy of confess. Let me put it here. And similarly, we can check whether John has a dominant strategy or not. In the same way, ask two questions. If Mike confess, what will John do? So if Mike confess, we are in this role. So we're going to compare this payoff with this payoff, and clearly 5 years sentence is better than 14 years sentence. So John will confess. Second question, similarly, if John not confess, what will Mike do? Oh, sorry, if Mike not confess, what will John do? So if Mike not confess, then we compare this payoff with this payoff, and it is clear that 1 year sentence is better than 1.5 year sentence. So John confess. So indeed, we can see that confess is John's dominant strategy as well. So John is going to confess, Mike is going to confess. So we see that this is the outcome that we are going to predict for these games. So let me erase this. So this confess is, we call this a dominant strategy equilibrium. Dominant strategy equilibrium. Okay, but wait, let's check. Confess and confess, both Mike and John, they get a 5 year sentence. But let's wait. Let's have a second look at this table. Can Mike and John do better than this? Yes, there's a better outcome here. There's better outcome here. If both of them do not confess, then the sentence is 1.5 years. It's better than 5 year sentence. Unfortunately, both John and Mike, they act out of their own interest. This better outcome cannot achieved. Okay, we call this situation a prisoner's dilemma. So players, both Mike and John, they have dominant strategies, and dominant strategy equilibrium is not the best outcome. So there's a better outcome that cannot be achieved.